Hey, welcome to The Explainer. We all think we know what memory is, right? But what if our most basic idea that it's something that happens just inside a brain is completely off? Today, we're diving into a really radical idea that memory isn't just a biological trick, but a fundamental property of any system that's just trying to stick around.
So let's just jump right in with a huge question. I want you to forget the whole idea of memory as some kind of filing cabinet in your head where you store little facts. What if that's just the wrong way to look at it? What if memory is actually an unavoidable side effect, an emergent solution that just happens in any system, whether it's a single cell or a complex animal that's simply trying to keep itself going? That's the big puzzle we're going to try and solve today. And to solve that puzzle, the first thing we have to do is completely reframe the concept. We're going to explore why memory isn't some special feature for brains, but actually this incredibly elegant solution to the very basic problem of staying organized enough to even exist. To really get this, we've got to forget about brains for a minute. Let's just focus on the core challenges of being an autonomous thing. Any system trying to maintain its own identity in a messy, chaotic world. We're talking about a single bacterium, a person, even a complex AI. They all have to solve a fundamental set of problems just to keep going. And memory, as you're about to see, is pretty much the master key to all of them.
So, what are these universal problems? Well, it turns out there are five big ones. And these five challenges are the evolutionary pressures that don't just, make memory a nice thing to have, they pretty much demand its existence. Let's break them down one by one. First up, viability. This is the absolute basics. How do you stay in the game? How do you keep a stable internal state and, not get destroyed? Well, any agent that can remember, hey, that glowing red thing is hot, has a massive advantage over one that has to relearn that painful lesson every single time. Memory lets you be proactive, not just reactive, which is way less costly. Second is what's called organizational closure. This is really all about maintaining what makes you you. Think about it. Your body is constantly rebuilding itself, replacing old cells with new ones. How does it know how to put everything back in the right place? Well, it relies on a stored pattern, right? An informational blueprint. That blueprint is a form of memory. It makes sure the system can rebuild its own identity, reliably, over and over again. Third, every system has to deal with uncertainty. The world is a wild, unpredictable place, and a fatal surprise could be just around the corner. There's this really key idea in neuroscience called the free energy principle, which basically says that to survive, you have to get better at predicting what's going to happen next to minimize surprise. And how do you build a good predictive model? You use your memory. Memory is your database of past events that lets you spot patterns and make a decent guess about what's coming. Number 4 is control capacity. See, it's not enough to just survive. A system needs to be able to act and influence its environment. It has to avoid getting backed into a corner where it has no options. And memory is absolutely crucial here. By remembering, okay, last time I did X, Y happened, an agent learns how to navigate its world in a way that keeps its future possibilities open. And finally, number 5, efficiency. Just existing is hard work. Calculating things, exploring, reacting, it all burns energy. Memory is the ultimate energy-saving hack. Instead of having to figure out the solution to a problem you've already seen, you just recall it. This reuse of information is a massive efficiency gain. I mean, it's the difference between inventing the wheel every single morning and just getting in your car and driving. So there you have it. Viability, organizational closure, uncertainty regulation, control, and efficiency. These are the 5 fundamental pressures of just being an autonomous thing. And the beautiful part is, memory isn't just a solution to one of them. It's this incredibly elegant, cross-cutting solution that helps with all 5 at the same time. And this quote just nails it. Memory emerges as the informational infrastructure of autonomy. It's not some extra feature, it's the base-level software that any self-regulating system naturally develops to solve the hardware problem of staying alive and organized in a really complicated world. Okay, so we've talked about why memory is so incredibly useful, but that just leads to a much deeper question. How does it physically form? How does a fleeting experience leave a permanent mark on something? Our next section explores the engine that actually makes this possible. I mean, how does a system with no memory start to form one? How do these temporary events leave a lasting physical trace? Well, a really powerful explanation comes from a theory called constraint resonance emergence theory. Yeah, it's a mouthful, so we'll just call it CRET for short.
So what on earth is Crete? Okay, imagine a huge stadium full of people, all clapping randomly. It's just a bunch of noise. But then, by pure chance, a few people happen to clap in the same rhythm. Other people hear it, they join in, and pretty soon the entire stadium is clapping in perfect unison. That synchronized clap is a stable pattern that emerged from chaos, just through reinforcement. Crete says memory forms in pretty much the same way, through a kind of resonance, a harmony of feedback loops all across the system.
This breaks down that whole feedback loop. Just look at the flow here. It starts down at the microscale, with tiny, fast, random events like individual neurons firing. Then, some of these random firings happen to form these little repeating loops at the mesoscale. That's upward amplification, a pattern starting to pop out of the noise. But then, the macroscale, the system's big picture goal, like say survival, acts like a filter. It reinforces the patterns that are actually useful and just lets the other ones fade away. That's downward selection. It's this constant cycle of creation from the bottom up and filtering from the top down that forges a stable, useful memory. And this is where it all comes together, in our final and, I think, most profound section. When we combine those 5 big problems of autonomy with this REIT engine, we get to a pretty startling conclusion about what memory really is. This table is basically the grand synthesis. It shows how that Crete engine solves every single one of the 5 problems we talked about earlier. So for viability, the system preserves the resonant patterns, the memories that kept it safe. For control, it encodes the patterns that led to good outcomes. For efficiency, it just reuses prior information as stored work. In every single case, the problem acts as a kind of constraint. And the memory that forms is simply the resonant structure that best satisfies all those constraints at once. And this quote just captures it perfectly. Information becomes structure, and structure feeds back as expectation. Your past interactions, that's the information, leave a physical trace, literally changing the structure of the system. And that new structure then shapes how the system anticipates and responds to the future. The past literally builds the present, which in turn gets ready for what's next. It's a beautiful loop. So here is the final crucial takeaway. The logic here is pretty much inescapable. If a system is stable and it has these kinds of feedback loops going across different scales, then some information has to persist. And that persistent information is, by definition, memory. So, memory isn't some special optional upgrade for fancy brains. It's a necessary, inevitable property of any system that just manages to stick around for a while. So let's end on a final thought here. If this whole principle applies to any self-organizing system, then that goes way beyond biology. It makes you wonder, what are the resonant patterns, the memories that are encoded in our societies, our economies, and our cultures? What past events have literally shaped their structure, and how is that structure now guiding our future? It's a really profound new way to look at pretty much everything. Thanks for watching The Explainer.